In our project, we focused and developed under three different key performance indicators, which were firstly the model visit frequency to identify how are the different models used across the various departments on the company. Secondly, the consecutive visit per name view category in order to track the repeated interactions of the users within the same category and in the same day. And lastly, the total time spent per day, which overall gave us some insights on the engagement and effectiveness of the interface. All of these KPIs were derived from a comprehensive analysis that we did our initial database with the help of our studio software that we cleansed the data and helped us arrange a better organization of the database in order to perform the analysis.
We wanted to identify the indicators that had the most important impact on the three areas of supply, commercial, and industrial. We conducted a statistical analysis and we discovered that the most visited modules were Flash, stock, production, and logistics, and the users that had the most interaction on the dashboards and on these modules were the manager, the traffic leader, and the coordinator. For our indicator of module visit, we conducted several different tests to compare if the means and the medians were all the same throughout the usage. Significant differences were found, and it suggested that there are many levels of the interest the users have on all the different modules. There are modules that are more used and others that are less frequently used. Modules like Coverflow and Flash attract varying numbers of visits compared to others, and what we wanted to identify was which module groups share the same mean, median, and certain statistical similarities.
For the metric of consecutive visit per name view category of a user per day, we did two tests, the matrix plot for consecutive visits and the one-way normal anom. Based on the matrix plot, given the very weak negative correlation and its proximity to zero, it suggests little to no practical change in the pattern of consecutive visits across the different years. And based on the graph anom, in the year 2020, the mean of consecutive visits is significantly higher than the overall mean, as indicated by the red dot above the upper decision limit. In the year of 2021, the mean appears to be within the acceptable range close to the overall mean. In the year of 2022, the mean is significantly lower as indicated by the red dot below the lower decision limit. In the year of 2023, the mean is within the normal range close to the overall mean. And in the year of 2024, the mean is close to the upper decision limit but still within the normal range.
The statistical analysis of the total time visit per day shows that there were a lot of differences between the average times on the visits because there were some positions that use more and with more regularly the system than others because, for example, there are 24 positions that only use the system 5 times in their whole years of the data, so that decreases the amount of time that they are on the site.
Based on the analysis results and the recommendations that my classmate will make shortly, we predicted 4 future trends that could be implemented into Ternium's database and overall intranet in order to make it more effective and efficient. This will be, first of all, personalized user interface based on the work position, context-aware dashboard displays that take into account the history of the user, as well as increased mobile integration for an easier access in every time that the user wants. And lastly, adaptive learning interfaces as well, based on the history of the user and its position.
Our recommendations are as follows. The first one is to highlight key models with the highest user engagement for a more intuitive use, and learn more about the underperforming models to understand if it's a design issue or it's more of a usage. Our second recommendation is to improve the data entry process to include more robust validation rules about the name to avoid getting more data about the name view repetition in order to understand more about the user's use of the dashboards and understand more about their single sessions. And our third recommendation is to implement a dynamic user system that adapts these dashboards based on the most frequent pages they visited, the use they have, and especially their position. Let's see if a manager could have a more dashboard that has more feature-rich system rather than another position that could only use up to 2 or 3 module pages. These customization dashboards can highlight the features and the data they use more for a more intuitive use.
Well, throughout their news analysis, our team identifies some insights about the employees' interactions with the systems, like we observed differences in the model visits that could be influenced by the user role, or the department function, or even the user habits. Models like Flash and Coverflow have a lot of engagement, and they show like their importance on the daily operations. Meanwhile, there were others that they weren't actually that popular, and some statistical tests that we did, like at the Novak, also confirmed the differences in the patterns across the different models and the categories. And all these findings validate that there's a necessity of a more tailored approach in the dashboard designs that could help to emphasize a more centric modification and enhance the efficiency and the engagement.